All right, scientific notation, day 3. So today we're going to continue to review scientific notation. I'm going to do a couple of example problems, and I'm going to show you a magic trick in the calculator. All right, so first let's go ahead and go through a couple of examples. So first of all, they're asking us, when you move the decimal point, how can you know whether you're increasing or decreasing the number? So let's say we have our decimal here. If I move my decimal this way, I'm making my number smaller. If I move it this way, I'm making it bigger. How do I know? Well, the more numbers I have in front of the decimal, the bigger the number is, right? So that means if I move it like that, it's going to get bigger. Okay, we're going to skip number 2. Let's go ahead and jump into it. So write each number in scientific notation. All right, so first thing I'm going to do is I'm going to look for my decimal. Now I'm going to go ahead and look for a space in between two numbers that gives me a new number in between 1 and 10. I'm looking. I see my space. I want to do 8.29 because that's bigger than 1, smaller than 10. So I'm going to count the spaces. 1, 2, 3, 4, 5. 5 spaces. So I'm going to take just this number part. Some people call it my coefficient. I'm going to rewrite it. Multiply times 10 to the power of, again, 1, 2, 3, 4, 5. 5. But wait a second. This was a small number. So this has got to have a negative. All right, next one. Same thing again. Let me locate my decimal. I'm going to look for my new place. I found it. All right, so now I'm going to pull out my coefficient, 3.02, times 10 to the power of something. Now, I look at the number and I'm like, well, that's a small number. Let me write in my negative so I don't forget. Okay, let's go ahead and count the spaces so we can get the rest of that exponent. 1, 2, 3, 4, 5, 6, 7. And there's my answer. All right, next one. A typical red blood cell in the human body has a diameter of approximately that many meters. Write this diameter in scientific notation. So they gave us a lot of nonsense to ask us a simple question. We got this. First, I want to identify my decimal. Now I'm going to identify where I'm going to put it. Now, don't let you be fooled by the fact that that 7 is the very last number. Can I put it here? Of course not. That's still smaller than 1. That makes no sense. So I'm going to put the decimal at the very end. Now I'm going to go ahead and take my coefficient. Some people write it 7. Other times you can write it 7.0, but we don't really need that. Times 10 to the power of, I know this is a negative because it's a small number. And let's count the spaces. 1, 2, 3, 4, 5, 6. So there's my answer. All right. So here they're asking us to justify our reasoning. So explain whether 0.9 times 10 to the negative 5 is written in scientific notation. If not, write the number correctly in scientific notation. Okay, first of all, what were they doing? This is smaller than 1. So now I'm going to go ahead and write that in a sentence. The coefficient is not between 1 and 10. So it is not appropriate scientific notation. Okay, so how do I write that? Well, I could go ahead and expand this out and do all those other things, right? But let me take a shortcut here. Okay, where do I need to move this decimal in order to make this an appropriate scientific notation? Well, looks like I need to move it there because 9 will give me a number in between 1 and 10. So that's 1 space, right? So I'm making my number bigger. So that means that I should be able to do something with that exponent. So before I do that, let's go ahead and take the long way around, okay? So I'm just going to write it out here to the side. 0.9 times 10 to the power of negative 5. 1, 2, 3, 4, 5. So this is what my number looks like normally. So I'm going to say, all right, let's go ahead and convert it. 1, 2, 3, 4, 5, 6. So this is 6 spaces. So it should be 9 times 10 to the power of negative 6. Okay, interesting that that 6 is one lower than this one. So I made my number bigger, so I would just change this one 1 because I moved one place. Okay? All right, next one. Which number is larger? 2 times 10 to the power of negative 3 or 3 times 10 to the power of negative 2? So, that's pretty difficult. But you know what? I can convert these back to normal numbers and compare them, or I can also just take a look at their exponents. So, whenever I have a number that is smaller, it has a negative exponent. And the more negative a number gets, so going from negative 5 to negative 6, negative 7, negative 8, negative 9, that means that the number is smaller. So I know for a fact that's more negative than this guy over here. So I would guess that he is probably smaller. But let's check it out. Okay. 1, 2, 3. All right, over here. 1, 2. Now notice, what I said was true. This guy was smaller. Because look at that. That's way smaller than that. So that does mean that this one is larger. So whoever is going to be larger, all right, larger is always going to have the biggest exponent, while the smaller one is going to have the smallest exponent. So this guy is my answer, and I'll leave you guys to write this sentence. Okay, last couple of examples, and then I'm going to show you something on the calculator. So here, they wanted me to rewrite these as standard notation, regular notation. So 1.045, and I need to move 6 back. 1, 2, 3, 4, 5, 6. 0.000001045. Okay, so now is the perfect time for us to go ahead and check out our calculator. So I'm going to go ahead and go to my main screen of my calculator. I'm going to type in the original one, 1.045 times 10 to the power of negative 6. Okay, so up here, what I'm going to do is I'm going to type in my negative 6, remembering that sometimes this can be shown as an E, okay? So I'm putting this, I use second log to get to that 10 to the power of x. So let's go ahead and put in that exponent, negative 6. And just like we did with Pythagorean theorem, oh, hold on 1 second. Okay, hold on. Let me type that in again, negative 6. And then I'm going to hit over because I don't want my equal sign up there. Second, math, in order to get to test, we're going to select the equal sign. And now I'm going to type in my answer, 0.123451045. This was what they gave me. This is what I changed it to. So what I'm going to do is I'm going to hit enter. If it gives me a 0, I got it wrong. If it gives me a 1, I got it right. And look at that, I got it right. So, back over here. 9.9 times 10 to the power of negative 5. All right, so let's move back 5 spaces. 1, 2, 3, 4, 5. Okay, so let's go ahead and check that in our calculator. Originally, they gave us 9.9 times 10 to the power of negative 5. And we want to know, hold on. Got to hit my over arrow. And we want to know if that's the same thing as 0.123499. And guess what it is? Noticing that I didn't have to put that multiplication symbol. See? But I can put it either way. All right, so I got that one right as well. Okay, last one. Jeremy measured the length of an ant as 1 times 10 to the power of negative 2 meters. Write the length in standard notation. So 1, and then we're going to move back 2. Here's my decimal, 1, 2. So it's 0.01. All right, so I want you guys to go ahead and do the 15 problems on the very next page, and I will see you next time. Bye for now.